Okay, Assalamualaikum, selamat pagi, good morning, welcome back. This is SIG 2004 Sedimentology Part 1, Silicic-Clastics. So I'm going to continue with lecture number 4. This is lecture 4 number 2. We're still looking at the petrology and petrography of sedimentary rocks. So we've looked at the petrology of mudstones and also sandstones. So today, right now, let's look at the classification schemes for sandstones. What kinds of sandstones do you have? How do you name them? And how do you classify them? Okay. So the main basis of sandstone classification is based on microscopic investigation. You need a petrographic microscope because you need to be able to observe the mineral composition of your grains, okay, and also the fractions of different grain types. Okay, so classification of sandstones requires assessment of percentages of grain types present. For example, how many percentages of the grains are quartz, or how many of them are feldspar, and so on. Okay, so there are two of the most common classification schemes used in classifying sandstones is that of McBride 1963 and also Folk et al 1970. Okay, so remember Folk et al and also McBride. We'll be using that a lot in sandstone petrography. The basis is on the composition of the grains. It's based entirely on the composition of the framework grains. You're not looking at the matrix, yeah? So you ignore the matrix in these classification schemes. So let's look at the method of classification. How do you do the classification? Well, you need to do point counting. You take a thin section of your sandstone, you put it under the microscope, and you need to count the individual grains and take note of the textural properties and also the mineralogy, whether it's a quartz grain, a feldspar grain, or rock fragment. Okay. So you do point counting, and you've already done this in igneous petrology and mineralogy. Okay, so I'm not going to talk into too much detail here, right? But you do point counting, and the number of points you need to count is 400 grains, which is recommended. Okay, some people do it up to 600 grains. Okay, you make a grid, and you systematically count. You make one reading at each grid intersection for 400 points, right? Okay, but in this class, for the practical, we use a much easier method, because this is going to be time consuming. You don't have time to count 400 grains. We do a rough estimate. Right? You do a rough estimate of modal composition. Okay, how many grains of quartz and so on you count. You don't count individual grains, but make an estimate using these kinds of figures. Okay, you just compare with percentage diagrams. It's like using the comparison charts for grain size, right? So it's just a visual estimation. So you can imagine the grains being the black dots here, and you compare what you see under the microscope with these images, right? So if you get a density of grains which looks something like this, for finer grains, you estimate it to be 50%. No? So for coarser grains, you can use this kind of diagram, okay? And this is also 50%. Right? So it's just a visual estimation. You anggar berdasarkan apa yang nampak situ. Okay, visual. Okay, so you measure modal composition for different grain types. Okay, well, what types of grains do you count in these classification schemes, right? Well, let's look at the McBride classification scheme first, right, 1963. So this is the diagram. and on this triangle you have 3 end member points. Okay, so Q is quartz here. So if you go further, this is 0% quartz. Go further upwards, this is 100% quartz. Okay, there's a lot of quartz here. Okay, on the right point here, this is rock fragment or lithic fragments. Okay, so from 0% here and increasing to 100% here. Then you have feldspar grains on the left, going from 0 here to 100% here. Okay, so during your point counting or your visual estimation, you need to count the percentage of quartz grains, rock fragment grains, and feldspar grains. All right. In terms of percentage, remember that. So Q plus R plus F must be 100% the total. All right. Again, I need to remind you, we are ignoring the matrix. We're just looking at the grains only, even though you have matrix inside your sandstones. Okay. So the name of the sandstone is based on where it plots on the diagram. So let's say if you have in your sandstone thin section, you only see quartz grains, nothing else. So 100% quartz grain. So it's going to be a quartz arenite, we call it. Okay. So quartz and arenite. Aranite means sand. Okay. Sandstone. Okay. So you've heard arena, right? So so arena has a when you have these battles in an arena, the floor is made up of sand. So we call it aranite. All right. Okay, so it is based on the percentage. If your rock is 100% made up of feldspar grains, it's going to be an aqueous on the McBride classification, or leaf arenite, it's 100% rock fragments. But intermediate fractions, you got other names like subaqueous, sub-leaf aranite, feldspatic leaf aranite, and so on. Okay, depends on where it plots on the diagram. Okay, so it's like a ternary phase diagram in spectrology, right? So you plot based on relative percentage of the three different end members. So this is another classification scheme. This is Folk et al. The method is the same. You do point counting or visual estimation, and then you plot on this diagram, a triangle again, with 3 end members again. Okay? So you still have a quartz end member, rock fragment, R, and feldspar. So what's the difference between Folk et al. And McBride? So here, you consider chert fragments as rock fragments. Okay, so if you see any chert grains inside your sandstone, you have to put it under R. Consider as a percentage inside the fraction for R. Okay, for the McBride classification scheme, the cherts are considered as quartz here. Quartz, quartzites, meaning things where you have more than one crystal, polycrystalline quartz. And cherts, all of these are considered as quartz grains. All right, but in the Folk classification scheme, chert fragments are included with rock fragments. Okay, so remember, classification schemes are artificial constructs. They are made by humans, and so you can have different ways of classifying your sandstones in this case. These diagrams have been used for different methods of interpreting provenance and depositional history. We'll talk about that in another lecture later. Okay. So, but the names are almost the same, right? So you have a quartz aranite where you have sandstone with more than 95% fraction, more than 95% of the grains are made up of quartz, right? You still have aqueous here, but it's in a different zone now. The feldspar-rich sandstones are called feldspatic aranites, and your rock fragment-rich sandstones are called liferanites. Yeah, about the same, right? Just a few small differences. Okay, so remember, McBride and Folk, get used to them. We'll be using them in the practical, so you get some experience there. So we've looked at the different classification schemes for sandstones. We've looked at the method of how we get the relative percentages of the n member grain types. You have quartz, feldspar, and lithic fragments. Right? Now let's look at the major types of sandstones. Yeah? So I'm just going to use very general names here, which can be applied to both the McBride and Folk classification schemes. Yeah? So look at the quartz aeronites, the feldspatic aeronites, and the lithic aeronites. Okay, so we go one by one. Let's look at the quartz aeronites. These are the quartz-rich sandstones. Okay, sandstones where more than 90 reaches up to 95% of the grains are made up of siliceous minerals. For example, quartz, chert, and quartzose rock fragments, right? Polycrystalline quartz also. It can even be more than 99%, nearing 100%. Yeah. So it can't really reach 100% because it might have other things inside, like heavy minerals and so on, right? Now, in terms of macroscopic features, we've looked at this in practical for Introduction to Rocks also, right? Quartz-rich sandstones or quartz aeronites tend to have a white or light grey color to them, like this. This is a quartz aeronite. There's some iron staining here, but it's what we say a relatively clean sandstone. Not much in terms of matrix or clay inside it, right? Okay. So it tends to be white or light grey in color. It is typically well cemented with silica, carbonate, or hematite cement. Now this is a thin section under microscope of a quartz aeronite. So you have lots of these monocrystalline quartz grains, and then the yellowish minerals in between is carbonate cement in the form of the mineral calcite. Okay, so this is a quartz aeronite. Typically, you don't find much matrix inside the quartz aeronite. Many are matrix free, right? In other terms, they are texturally mature, right? Remember, quartz is a stable mineral, right? So other minerals can be weathered out and transported away. You are just left with quartz. This has been transported for long distances, or it has been reworked for long periods of time. But sometimes you do get quartz-rich sandstones with a significant amount of matrix. If the matrix is more than 10%, we call these quartz-rich sandstones quartz wackies. So matrix-rich sandstones, you just affix the term at the back here with wacky. Okay, so there's another classification schemes for mud-rich sandstones. But we won't cover that in this course. Now, the feldspar-rich sandstones are called feldspatic aeronites. They have less than 90% grains made up of quartz. You have more feldspar relative to rock fragments. Example of a hand specimen of a feldspatic aeronite. Okay. So notice the poor sorting in this case. See the feldspar grains. And the thin section, this is how it looks like. You can see plagioclase with multiple twinning in this case. Okay. With quartz in between also here. Okay. The common name for the feldspatic aeronites are the arkoses. Right? Feldspar values sometimes reach 80%, but this is rare. In terms of color, it varies from light gray to white, pink, or even red in color. Okay. You can have matrix inside your feldspatic aeronites, may range from trace amounts to more than 15%. Okay, so lots of variation in the matrix content of your feldspathic arenites. And the third major type of sandstone is what we call the lithic arenites. These are rock fragment rich sandstones. Sandstones with less than 90% quartz. Remember, quartz is very common, so a lot of the sandstones still have them, but it's going to be less than 90% in the lithic arenites with unstable rock fragments more than the feldspar grains. So notice here you have a siltstone grain inside your polysorted sand here with quartz also associated with quartz and feldspar. Right? Lithic arenites tend to have a substantial amount of matrix. But be careful when looking at these lithic arenites. When looking, you think you are looking at matrix, but a lot of the time it's not really matrix. It's actually rock fragments, maybe shale or siltstone, right? It's just that the boundaries are not clear under thin section, or the rock fragments have been crushed, okay, because they are relatively soft compared to quartz. Okay. So, but it's better to show you that under the microscope. Okay, so that's the petrology of the sandstones. We've looked at the classification schemes for sandstones, and it is based on the relative percentage of end-member grain types, which are quartz, feldspar, and rock fragments. There are two classification schemes, the McBride scheme and also the Folk et al. Scheme. The main difference is considering whether the chert fragments, chert grains, are part of the quartz end member or the rock fragment end member. Okay, so this is the final type of sedimentary rock we'll be looking at in this lecture. These are the conglomerates. Okay. So how do you define a conglomerate? A conglomerate is a sedimentary rock with a substantial fraction of gravel-sized grains. So this is a conglomerate, and that is a smartphone for scale, right? So I'm estimating here that is going to be roughly 13 centimeters long. Okay, so you have these large grains which you can see with your naked eye without using a microscope. So these are gravel-sized grains. You can look at the Arden Wentworth grain scale. Some of them might be granules or cobbles or pebbles or even boulders, right? So yeah, you need to have a substantial amount of gravel-sized grain, but how much? Folk puts the cutoff at 30%. Okay, so if you have gravel grains inside your bed, making up more than 30% of your bed, so that is going to be called a conglomerate. Okay, so you can divide conglomerates basically into two types. First, you have what we call a matrix supported conglomerate. I'm showing the example here, a photo here. This is a matrix supported conglomerate. Notice that the gravel grains here are not in contact with each other. They tak bersentuh, they're not touching each other, but they are floating inside a fine-grained matrix. Okay, so the matrix is actually supporting the grain, so we call it a matrix supported conglomerate. Okay, so other terms used in the literature are diamictites. So this can also be called a diamictite. Some people even call it a pebbly mudstone. Right? In this case, because you have less than 50% gravel. So this is also a conglomerate, but this is a class-supported conglomerate. The gravel grains are very dense here. A lot of them are touching each other. You have point contacts everywhere, even in long contacts, right? So in the case of a class-supported conglomerate, you have little matrix. The grains touch each other to form a supporting framework. All right. Other terms you might meet in the literature: pebbly sandstones, sandstones containing less than 50% gravel, pebbly mudstones like this one containing less than 50% gravel. You might also you also meet the term braccia. This is restricted to conglomerates with angular grains, but you can still call them conglomerates, right? That's the general name for them. Okay, so that's it for today's lecture. That's lecture number 4. See you next week. Okay? So these are some references. Good books to have. Box. A significant amount of material for the lecture is from box, and the classification schemes come from reading these books here by Folk, and papers by Folk et al. References for the classification schemes are here, Folk et al. 1970, and also McBride. Okay, and a few other books. Good if you are interested in sandstone classification and petrology. Okay, that's it. Bye.